Usually when proving identities, we start with the side that has more things to work with. And here that's going to be the left-hand side. We're going to need to combine these two fractions, so we'll need a least common denominator, which is going to be the 1 minus sine of x times 1 plus sine of x. So the first fraction would look like 1 minus sine of x is what we're given to start with, and then multiply by 1 plus sine x for the numerator and denominator. And for the other fraction, we were starting with 1 over 1 plus sine of x. So then multiply by 1 minus sine x. Do that for the numerator and denominator. And now we have one fraction that for the denominator has 1 plus sine x times 1 minus sine x. And we might as well multiply that out. So it's going to be a 1. The middle term right here would be a positive sine x, and here would be a negative sine x, so they cancel. So far we've just got a 1 times 1. And then we've got the last term times the last term, which is going to be negative sine squared. And then for the numerator, we've got a 1 plus a 1. That's going to be that 2. And in here we've got a positive sine x plus a negative sine x, so they actually cancel. The next thing to do is realize that 1 minus sine squared is equal to cosine squared. That comes from the Pythagorean identity that sine squared plus cosine squared equals 1. So if you subtract sine squared from both sides, we've got that 1 minus sine squared is equal to cosine squared. So that's the next thing to do. So we've got 2 over cosine squared. And since we know that 1 over cosine is equal to secant, the same is true with the square. And so this 1 over cosine, you can also look at it like this, that the 2 stays there, and then you've got 1 over cosine, so that's secant. And because it's squared, we've got secant squared. And then I just like to label that that is the right-hand side, and I started with the left-hand side. And so it's been verified.